A while back, I posted a series of presentations featuring the subject and fire assay. Starting with part 1, if one was to view each presentation, one would have completed a fire assay course designed for the small miner, prospector, and/or a hobbyist. It was not designed for the professional mineral assayer or laboratory technician, or even a geochemical analyst. Fire assay is a method that was mainly used for the separation and the analysis of gold and other precious metals. But what about copper, antimony, cobalt, barium, and other industrial metals of interest? Well, in this series of presentations, I want to discuss the subject of chemical analysis. I will endeavor to try to explain the subject matter in plain English, as well as design these presentations as an equivalent course for small enterprise miners, prospectors, and or hobbyists, not for the scientist or chemist. Most textbooks, if not all, refer to these methods still being used today as some of the oldest, and as such, because of this fact, it has been termed as classical assay, and therefore I have decided to call this series as Classical Chemical Assay for Small Miners, Prospectors, and Hobbyists. There are two categories of classical assay, and it must be understood that classical assay is basically a wet chemical analysis. We dissolve the sample in a chemical solution, then chemically extract each element or group of elements for analysis. The first category is referred to as qualitative analysis. This method is conducted to determine, that is, to identify the components that make up, or simply put, is in your sample. This method is used to identify what you have, not how much you have. The second is quantitative analysis. This method is conducted to determine how much you have, which relates to the concentration of the elements of interest within your sample. Qualitative analysis is useful for the determination of interfering elements or compounds before conducting a fire assay and/or chemical quantitative analysis. Quantitative assay is useful as it can determine the concentration of silica and more. The determination of silica would be necessary for the silica, that is, the component to be calculated for the flux requirement in fire assay. Instrumentation may be used for qualification, but mostly used for quantitative analysis. Instrumentation requires the samples are dissolved in a solution. The exceptions are X-ray diffraction, X-ray fluorescence, and maybe neutron activation spectroscopy, where samples can be solids. However, instrumentation is expensive to purchase and expensive to maintain. Classical chemical analysis is much less expensive compared to instrumental. All that is required is glassware and associated hardware such as stands and clamps, a hot plate, a good lab scale, a centrifuge, and a fume hood. It is true that analytical grade chemicals are expensive, but small amounts are used, which goes a long way, making them affordable in the long run. Instrumentation is designed to analyze samples of low concentrations, in the parts per million and parts per billion range. Instrumental is not suited for samples that contain higher concentrations of analyte. Wet chemical analysis is best suited. Wet analysis for qualification can be fast and inexpensive. Mining companies build laboratories on site, as smaller labs do not require large amounts of real estate, only small physical spaces. This would be a benefit for a small operator or a prospector, even a hobbyist. A small form of a lab can be assembled on site, even in your garage or basement. Always remember safety and ensure adequate ventilation. It can also be fun to play, experiment, and learn by following predefined steps or procedures. An individual can learn quite a lot, and with the gained knowledge improve the processes as well as develop new methods for analytes in different matrices, that is, in regards to your ore types. There are two qualitative methods, a Marco method and a semi-micro method. The Marco method requires a sample weight of 0.5 to 1.0 grams. The semi-micro sample weight can be reduced by a factor of 10 to 100. The result is that the scale of operation can be reduced, while the concentration of analyte remains the same. It is for this reason all discussions will be based on the semi-micro method. As one can imagine, there are advantages for using the semi-micro technique. I mentioned earlier it was speed. Smaller sample volumes will shorten processing time, such as washing and decanting, evaporation, titration, and more. There is also sharpness in regards to analyte separation. There is also some efficiency as centrifuges may be used, compared to a slower filtration process. Small handheld operated centrifuges are available and are cheaper compared to a full-blown lab model. Smaller volumes means that less chemical quantity is required, which results in a lower cost per analysis. This part is part 1. It is just an introduction to this new series. Part 2 will introduce you to what a separation scheme looks like, what the groups are, and the analytes within each of the groups. I hope that you found this short presentation interesting, although maybe boring, and will entice you to view Part 2 when it is published. As always, if you know someone who would benefit from these presentations, please pass on the link, subscribe, and like. There is no joining, and I do not advertise product, but at times I may mention a supplier. I receive no financial benefit. My channel is strictly educational and not for profit. Content may be downloaded freely and distributed freely, not to be sold. As a student myself, I firmly believe that education should be free and passed on. Knowledge is priceless. Therefore, no price can be placed upon it. I am Rob Boyko, Boyko Mineral Exploration, and I hope to see you in Part 2.